Okay, so speed is distance traveled in a certain amount of time. And most of the time we're going to be measuring these in meters per second, but any distance over time works. We use miles per hour, but most of the time you'll see meters per second. All right, so the formula that we used was speed is the change in distance divided by the change in time. And at the end of class, Ashley asked a really good question. How do you know which one is the first one and which one is the second one? So down here where it says D2 and D1, your final speed is your ending speed. That's the one you're going to put first. And the initial speed, or distance, I forgot an I in there. Initial is your beginning speed. That's when you're going to subtract. Same thing for time. The ending time goes first, and the starting time is what you subtract from it. Okay? What else did I put up? This little picture says a car 4 meters away for 2 hours has a speed of 0 because it hasn't moved. So we're talking about change in time and distance. So if you're not moving, you don't have a speed. You have to be moving for this to work. So let's go through a few of these. They've worked out this first one completely already. A plane flies 4,000 miles in 5 hours. What is its speed? So we worked with this setup yesterday. You need to know what variables they gave you. 4,000 miles is going to be what? A distance. And 5 hours will be time. And they're asking us to solve for speed. So they've already did this over here. Why did they go ahead and just say the change in distance is 4,000? It started from what?
It started from 0.
It started from 0. Yeah. So 4,000 minus 0 just stays 4,000. Same thing for time. It started at 0 time and went for 5 hours. So if you're starting from a stop, then you don't really need to do the subtraction. They're going to be the same thing. And then our formula is speed equals distance divided by time. So they put that in here. What is 4,000 divided by 5? 800? And then our units this time was miles per hour. Okay? So make sure you've got units on here to make them correct. Questions about that? Pretty simple what we did yesterday too.
Is that
HR for hour. The box kind of cuts it off. Okay, let's look at this second one. A car travels from 20 meters to 60 meters in 10 seconds. Calculate its speed. So what did they give us first? Distance. They gave us 2 of them. So we have distance, our first distance and our second distance. And then what else did they give us? They gave us time. They only gave us 1 time though. So what's that about? We're still gonna, we're gonna do this to put it into the speed formula.
Right.
But since they only gave us one time, what do you know the other one has to be? 0. They started at 0 seconds and then counted up to 10. So we don't have to do the subtraction there. I guess that would be T2, sorry. That's our ending time. So they gave us distance, they gave us time, and they want us to find speed. What formula? It's right up there. But what formula do you use to find speed? Delta D over delta T. Do we need to change anything around? Okay, we do need to go ahead and do the distances, but do we need to solve for something else, or are we already solved for speed? Okay, so that's good. We don't have to do that step. For 4, we're going to plug in the numbers. So I don't know what my speed is. I'm going to keep it the variable. And then I'm just going to do this all in one. So delta D means what? Yeah, we got to subtract our distance. What's it going to look like for this problem? Yeah. 60 minus the 20. The ending minus the beginning. And then our change in time. Yeah. It's just the 10. And then we'll go ahead and do this. What is 60 minus 20? 40 over 10. 20. So we're going to actually solve it for step 5. 40 divided by 10 is just 4. And then what are our units? Meters for the speed or the distance, second for the time. Okay? Questions about that one? All right, let's look at this last box. A car travels at 60 meters per second. What is that? This is giving you speed first, so a little different. For 8 seconds. That's time. This time they want us to find distance. So they gave us speed. What is that? 60 meters per second. We have time. That's just 8 seconds. And we need to find out what the distance is. So we're still using the same formula. Yeah, we need to move it around this time though, because they want us to find distance. What has to happen to get the D by itself? Good. Distance is dividing by time, so we need to multiply by time to undo that. So then for step 3 up here, delta D is by itself. What's the other side look like? S times delta T. All right. Now we plug in. We don't know what distance is. Speed was our 60 meters per second times time was 8 seconds. Okay, so the math you're going to do here. That's not good. What is 60 times 8? 480. And then let's talk about what happens to our units this time. Okay.
Since you're traveling at 60 meters a second.
Distance was in meters. And if you look back up at our problem, we had a seconds on the bottom and a seconds on the top, so they're going to cancel each other out. That's why all that's left there is meters. If you forget what units look like for whatever you're solving for, you can literally just go cancel things out up there to help you. Okay? Questions about this top half of the paper? No? The bottom half of this page is talking about experiments. So this part is mostly just some vocab we need to go through. The scientific method uses these 6 steps. First, you research. Then you make your question. Form your hypothesis. Do some experiments to test your hypothesis. Collect your data. And use your data to draw a conclusion. So they go in this order. They've given you this mnemonic, what is it called? Mnemonic device? Really quiet hippos eat dark chocolate to help you remember the order those words go in. You'll also just have this page. You like them, yeah. Just like that, to remember all your, yes. Just know that you need to follow the steps in order. When you're doing an experiment, that's how you gather your data. You can't prove anything without showing your work. Your experiment is your work. If they're going to lead us to knowledge, we better know how to do them correctly, because if you mess up your experiment, then your data is invalid. So, we are going to do an experiment today. Yes. You just wait and see, okay? When you're doing an experiment, you run different trials. A trial is just each time you do the experiment. To actually have good, valid data, you need to do your experiment multiple times, several times, because sometimes your data might just be something weird happened. You want to see that it's occurring over and over again to say that it's actually real. Okay? So you'll put your data into a table. This one has trial, and then they were timing things. So each time they were seeing how long it took. And then since they have multiple trials, you take the average of those to get a number to work with. So putting them together is better to see what actually happens over time instead of just picking one and saying that that's what's going to happen every time. Okay? When you're doing your experiment, you're testing variables. For ours, we're going to be talking about speed. When you're finding speed, you're looking for distance and time. So those will be our 2 variables today. And then your procedure is how you did your experiment. You need to make sure, like an actual lab, everybody's working on the same experiments, needs to make sure they're doing them the same way so that they get the same type of results. If you do something a little bit differently, then you've done a totally different experiment. So we're making sure following procedure, and it's it's just directions, okay? All right, so there's that vocab. On the back of this, we've got some questions like we did yesterday. This first section is just the vocab we just talked about, matching. I'd like you to go ahead and do that on your own. And then we did these match the variable to the quantities yesterday. If you didn't get a paper yesterday, you're going to want that table. I will get that for you. And I want you to do that one and the math functions sections on your own, please. Okay, what is a variable? Okay, the part of the experiment that you're changing or manipulating. A procedure. A, how you do your experiment. Your data table. Yeah. The information you got. A trial. When you run an experiment, okay, and then an experiment, how you actually gather data. All right. Those two, I'll just grade. Let's go through. Let's do this last. A equals delta S over delta T together here. Solve for delta T. All right. So we want to solve for delta T, but also we just have this fraction that I can't do anything until we undo. So the opposite of a fraction. Fractions mean divide, so we need to multiply by whatever's on the denominator. All right. Delta T times A will equal delta S. And then to get delta T by itself, divide the A. Okay, so delta T equals, we're just going to rewrite that, delta S divided by A. I got a little squished. I'll move it over. Okay, those other three before that are asking you to do the same thing. Go ahead and work through those three. And then we'll do the word problems. What'd you say? Yeah, so if you're watching the video, pause and work through the first three. You guys in class, go ahead and do those and then we'll go through them. Okay, for F equals MA, multiply by A? What's happening with A? We want to get A by itself. It's multiplying with M, so we need to divide it. Good. What do we want to divide by? The M. We want A to stay there. A equals F divided by M. Good. We have our speed formula, delta D over delta T. We want to get delta D by itself. Good. It's a fraction. Fractions mean division, so we need to do the opposite. Delta D equals S times delta T. All right. And then we have delta D equals D2 minus D1. Remember, those are just subscripts. It's just saying the second one and the first one. What do we do to get D2 by itself? Add D1 on both sides. So D2 equals delta D plus D1. Okay, questions there about moving things around? No, you will not be. Last thing we're going to do is a word problem. All right, let's do this first one. A bike moves 50 meters in 5 seconds. That's fine. We're going to do all of them. What is 50 meters?
50 meters
Distance. So down here for delta D, I'm going to put 50. 5 seconds is time. And then we don't know our speed. We're solving for that. Good. Our formula is S equals delta D over delta T. Do we need to move anything around? No. They asked us to solve for speed, so we're good. Plug in your numbers. 50 over 5, all right. Meters and seconds. It will be 10 meters per second. Make sure you've got those units on there. All right, and then let's do the one right below it together. This one says a car travels 60 meters per second for 60 seconds. So what do those stand for?
Time.
60 seconds is time.
Speed.
And meters per second is speed. We don't know what the distance is. All right, so speed is 60 meters per second. Delta D, don't know. Delta T was 60? Hmm? So when we do this, still working with speed, our formula is still S equals delta D over delta T. Is this what we want to plug into? Is it solved for what we're looking for? No. What needs to move? Yeah, multiply by delta T on both sides. We want distance by itself, so D, delta D equals delta T times S. If you have S times delta T, that's fine. They mean the same thing when they're multiplying. All right, so plug in your numbers. Delta T is 60 seconds. Speed, 60 meters per second. Careful.
Nope.
60 times 60, not 60 times 2.
360.
Yeah. Wait, you said... But they both had a 0. So the 6 times 6 is 30, but then 2 more zeros. 3,600 meters. Okay. I want you to do these other two on your own. Take about 5 minutes to do that, and then we're going to do our speed experiment.
Is it going something else?